Hello, and thank you for tuning in to this very special video of how to prove or derive the quadratic formula. Okay, just a word of note, you don't need to know the proof of this for the section you're doing now. Okay, but there is going to be a unit coming up called mathematical proof, and this is a very nice, it's a lovely proof to show you. Okay, because all it involves is a bit of algebra. Okay, just a bit of algebra, or several lines of algebra to be honest. Okay. But it is going to be a helpful introduction for you into how mathematical proof works, okay? Because one of the ways of proving something like this is to use a direct proof, okay? It's the best method as well, okay? So how do we derive that? How do we prove the quadratic formula? Because for the moment, a lot of you have been using that, okay, to solve equations, okay? In the GC exam, you probably came across an equation and thought, right, let's turn to the formula page. Yeah, thank you, magic formula. We'll just use that and there we go, our answers, okay? Well, there's nothing magic about this, okay? Let me tell you now, there's nothing magic. I don't call this the magic formula, okay? It's a formula that's been proven to work, okay? It's called the quadratic formula, okay? In this form, it's derived by René Descartes, French mathematician, okay? And one of the methods that can be used to derive it is by using completing the square. Yes, completing the square returns again, okay? And seeing this proof will give you a good recap of how completing the square works, okay? Because you're going to do it without any numerical values, okay? That's how we do it. That's what we're doing. We're trying to find a general solution for this with a as the coefficient of x squared, b as the coefficient of x, and c as a constant, where a, b and c are any numerical values, okay, that we use, okay? Right, let's go. If you remember, or if you've watched a video on solving the quadratic equation using completing the square, something like this came up, okay? And I did say it's a good idea when your coefficient of x squared is not a to divide throughout by that coefficient, okay? So that's what I'm going to do first of all, divide throughout by a. So it gives me x squared plus b over a x plus c over a equals 0. Now I should point out that you don't have to do that, that's just what I'm doing, okay? Because some people prefer to take a factor of a outside the brackets, okay? But my view is, because we've got an equation with 0 on the right hand side, simplest thing, just divide that by a, okay? You'll find if you look this up, if you do a Google search for the proof of the formula, okay? The lines, the steps in working are not always going to be the same as, you know, whatever you find online, okay? There are going to be differences. Now what I'm going to do is I'm going to complete the square on that, okay? So remember the method, okay? So we're going to have something in brackets, x, and the symbol there is the same, plus, and then we want to half the coefficient of x, so half in b over a is b over 2a. That's literally right, there's a half of b over a. Now remember, half of b over a is the same as doing that. 1 times b, 2 times a, hence b over 2a, okay? And squared. That's that. And the next thing we want to do in completing the square, of course, is to square that, okay? So if you square the top, you get b squared, and square the denominator, you'll get 4a squared. And we want to subtract that, of course, because that's what we've been doing throughout when we've been completing the square on an expression or using to solve an equation. And then we've got the plus c over a there, okay? Now, I'm going to write c over a for the moment, but what I really want to do is have a common denominator between these two terms there, okay? So if I just write it over here, c over a is going to be exactly the same as b squared c over how, what did I say that for? So I must have been thinking of something else, okay? It's the 4a squared I want, isn't it? Okay, so 4a squared, so I'll keep the c there, and I'm going to multiply top and bottom by 4a. Does that make sense? Okay, yeah, because if I've got c over a, if I want 4a squared on the bottom, times it by 4 like that, see, okay, and then multiply top and bottom by a, so put that squared there, and just, I've just written that in alphabetical order, so 4ac over 4a squared. Sorry for nonsense, I don't know, yeah, okay, but as with before, I don't, the way I film these videos is if I'm doing it live in a lesson, okay, I don't stop and have another go. I don't think, oh, I shouldn't have said that, let's just rewind or pause. No, it's kind of, I'm trying to make it more real to life, okay, because I want these videos to be the next best thing to being in a classroom. That's the whole point of them. Okay, it's not everyone's cup of tea, but you know, it's how I do things. Okay, and you might find it slightly more entertaining the way I do it like that as well. So yeah, that's my next line. Okay, all right. I'm going to see if I can fit it all on one board. Okay, let's see how it is. Next, I want to group these together and put them over there. Okay, so I'm going to keep the brackets x plus b over 2a exactly the same. Now, usually it's preferable to have the equals sign all lined up. I've kind of not done a good job there, have I? Okay. But because the right hand side has got a few things on there, and just got the equal side there now. Okay, sorry for the purists who are like, why does he not line up his equals? Sorry, this is what I'm working with. You know, a small board in the garage. Okay, not a big board in the classroom. So look, what I'm going to do is this. I'm going to have the same common denominator, 4a squared, and I'm going to group them together. Okay, how am I going to group them together? Well, if I add on the b squared, that's going to be positive, isn't it? And if I subtract the 4ac, that's going to be negative. Can you see how it's already starting to look like this? Okay, we've got the b squared minus 4ac there. We've got the discriminant already, which is pretty awesome, isn't it? Okay. What's the next step? We want to square root both sides. Okay, so we'll have x plus b over 2a, and then square root both sides. Okay, so for this we're going to square the denominator and numerator separately. So squaring the numerator, we'll have b squared minus 4ac. Okay, and the positive or negative can just go there at the front, and then the bottom. That is a perfect square. Remember, I've talked about those in the previous video. So the square root of that should be 2a. I can very nearly that now, isn't it? Okay. And the next thing we want to do is we want to put this onto that side. So it's going to be negative b over 2a plus minus square root of b squared minus 4ac all over 2a, which is the same as that. It's the same denominator, isn't it? Okay, 2a. Okay. Now you could argue I could just write down that line straight away, but I just wanted to fit that in just so you didn't miss it. Okay. And so that is the same as this. Okay. If I just keep it on one board, bye bye. I'm going to have it as x equals negative b plus minus root b squared minus 4ac all over 2a. Okay. And that's the proof. Okay. That is the proof of why the quadratic formula works, okay? Because what we've done is we've actually completed the square in this, and we've made x a subject, so that tells us our solutions has to be x is either negative b plus that all over 2a or negative b subtract that all over 2a, okay? I'm hoping that you enjoyed that one.